Thanks very much, Harry. Yes, a little bit of a departure from what we've had so far, and what I'm going to present on is a little bit about the latest climate projections for New Zealand. So that's really coming from NIWA's core work as well as collaboration with the Deep South National Science Challenge. Then I'll talk a little bit about modelled agricultural impacts. And now that work is, I'll be borrowing results from other collaborating institutions as part of a project that finished up in 2016 called Climate Change Impacts and Implications, which was a Endeavour funded project. It wasn't called Endeavour at the time, but it was a 4-year funded project involving many collaborators. So I'll talk a little bit about some of the work that came out of that, and then I'll try to show a little bit of a landscape of ongoing research projects in this space and climate change impacts in the agricultural sector. From my perspective anyway, I'm sure I'm missing out on quite a lot, but we'll finish off with that. So in terms of the latest climate projections, what I've got here, and I always struggle with two screens knowing which way to point, so I'm going to point this way. I hope that's okay. What we've got here is two projections of annual temperature by the end of the century. The first one on the left is based on a low emissions pathway, global pathway. These are representative concentration pathways. And then the one on the right is a high emissions pathway. So what these two maps, if you look at them side by side, really indicate is why we are concerned about reducing greenhouse gas emissions. So by the end of the century, if the world follows a low emissions pathway, then for New Zealand, we're talking about on the order of about a degree or so warmer than current, well, between 1995 and 2090. So we're still heading towards a warmer world, and also for New Zealand, by the end of this century, even if we limit our emissions to one of the lowest emissions pathways that the IPCC evaluate. In fact, this RCP 2.6 was designed to meet that global 2 degree, keep global temperatures at or below 2 degrees Celsius compared with pre-industrial. So we are certainly still going to see some warming for New Zealand. This is where we are projected to be if we go on the RCP 8.5 route, and that is often referred to as business as usual, although some people would disagree with that. It certainly does mean actually still a ramping up of emissions from where we are now in terms of global emissions. Now the difference is that these temperatures are all around that 3 to 3.5 degrees warmer than what we are now. So the difference between low emissions and high emissions, a 1 degree temperature increase in the annual mean temperatures versus 3.5 to 4 degrees is quite significant. Hence why we need to be in a global discussion about how we reduce our emissions. We can look at other, of course, climate variables. What we are able to do with these global climate models is take these prescribed emission trajectories or concentrations of greenhouse gases in the atmosphere and model what that means for the climate. Now, this is a big deal, right? And these are difficult models. They are, require the biggest supercomputers in the world to run. And at the moment, what NIWA do is we take global model output from overseas institutions, and we downscale to New Zealand conditions using our own regional climate model. That's our standard approach. The Deep South National Science Challenge, which is now sort of midway through its 10-year cycle, is trying to develop our own New Zealand-based Earth system model. So it's the first time ever that New Zealand will have our own climate model to then downscale for New Zealand conditions. And what the Deep South team, in collaboration with the NIWA climate modelers, are trying to do is ensure that in that model we take into account processes that we know are important to our part of the world. And in particular, what's happening to the south of New Zealand, hence the name of the challenge, Deep South. Anyway, these are projections that aren't based on that Earth system model. That's still to come. But basically, you can see now in terms of the annual rainfall projections, again, low emissions versus high emissions, and this is the annual total, that we're talking generally still a wetter country. So, but this is only in the order of sort of 0 to 5% wetter in most of the country. If you go to a high emissions scenario, then you start to see quite a difference between rainfall, particularly west versus east and south versus north. So generally speaking, South Island is wetter, particularly west coast. We're talking now up to 20% more annual rainfall. And generally speaking, there's this difference across west to east in the North Island of sort of up to 10% in the west, but a decrease in annual rainfall of that same order in the east, and particularly so also in the north of the North Island. So it's quite a different picture when you look at rainfall compared with looking at temperature. And this is a function of what we're expecting to see in terms of changes in our atmospheric circulation. Now I wanted to also highlight the fact that annual rainfall changes don't paint the full picture. We are going to see, well, our projections are that there will certainly be quite a different pattern of change depending on the season. And the annual maps that I showed are really being driven by the changes in the winter period. It's exacerbated in the winter in terms of the projected increase in rainfall for the west, particularly all south, well, west and south, and versus the east and north in the North Island. In the summer, it's actually quite a different picture completely. And there's still a lot of uncertainty. This is actually an average of many models. It's an ensemble average, and a lot of the different climate models that we use, different global climate models that we use and downscale for New Zealand, are showing quite different pictures for summer rainfall. So there's certainly still a high level of uncertainty associated with summer rainfall, whereas most of those models are showing a very consistent picture for winter rainfall. So I think this is at the moment our primary take-home message for rainfall, is that we're most confident that we're going to see that type of change in winter period. Now I'm going to show a couple more scenarios or pictures of the future climate where we go into a bit more into the extreme ends. By the way, all of these maps are freely available on this service that NIWA has called Our Future Climate New Zealand. So just Google Our Future Climate New Zealand and you'll be able to get any of these maps. And we're continually building up our repository of maps on there based on all the models that we use. Here's an example for hot days. Now, when I show this map or talk about the definition of hot days with my colleagues from Australia, they will have a bit of a giggle. Basically, this is any day where the maximum temperature is greater than 25 degrees Celsius. They would say that that's a cool day in some parts of Australia. In fact, their definition, I think, of hot days is now over 35, I think, in Australia. Anyway, we use 25, but basically what I'm trying to show you here is a picture that this is an increase across New Zealand, but particularly, of course, you would expect more of these hot days projected in the North Island. And the numbers are quite staggering. So these numbers up here, particularly in the North Island, are more than 50 additional hot days per year by the end of the century. Now, this is only based on the high emissions scenario. Now, we have maps that are based on different RCPs, and you can break this down by season. But significant increase in hot days could have particular implications for animal health, for example, but also for pasture production and other crops. Here's another, the other side of the coin, really. It's the number of frost days, or the number of days where the minimum temperature is below 0 degrees. And really now you're seeing the biggest decrease in frost days in the South Island, and that is essentially because that's the island where we have the most frost days at the moment. You don't see much of a decrease up here in the north of the North Island because you can't decrease that much from only one or even less than one per year on average. But now we're talking frost days. If I pick in my home territory of Southland, in that lovely agricultural land in Southland, then it's in the order now of getting up to 25 odd days fewer frosts per year in the South Island, in Southland. So it's quite staggeringly large changes in those extreme ends when we think about hot days and frost days. Drought is another really, really key variable, obviously, for agriculture. And this data is still actually from 2011, when Anthony Clark was at NIWA and did this report for MPI on the impact of climate change on drought. And really, what it is showing here is that even by mid-century, that we can see almost a doubling of, an increase of 10%. Oh, sorry, let me read this again. Those numbers, yeah, okay. So 10% in this red area of 10% more time spent in drought. And getting into the yellows, it's sort of into the order of sort of 8%, and the greens are in that sort of 5 to 6%. So we are expecting nationally having more time spent in drought, but particularly in areas in the south of Canterbury, Otago, and even eastern Southland. Now, this is relatively old now, but you'll be pleased to know that there is actually an ongoing project right now in the Deep South National Science Challenge to update all of those projections, and it's based on this new index called the New Zealand Drought Index. Now, if you haven't seen this, please Google New Zealand Drought Monitor, or you could even Google New Zealand Drought Index. It's an updated map of current drought conditions for New Zealand it's updated on a daily basis now on the NEWA website. This was from earlier this year, where we had quite a significant drought event in the north of the South Island. So all our new projections are going to be based on that same index. Now I'm going to get on to some agricultural impacts, and I'm really borrowing work from other collaborators here. First of all, from Friends of Plant and Food Research, who are using the Epsom model to look at changes in this case silage maize yields, but also now doing a lot more work on other crops. And the real beauty of the Epsom model is that it allows you to look at what the impact is of adaptation, as well as just purely on changes in productivity. So, for example, here's a projection. This is all based on RCP 8.5. It's only based on one particular global climate model for the end of the year, but it's looking at the yield change in silage if you don't have any adaptation measures, versus if you do look at adaptation measures, and they'll be, for example, the timing of sowing and different varieties, etc. So it does show you can have this nice way of looking at the benefit of adaptation, not just on everything's dire and it's going to production is going to reduce. So a lot of really good work going on from Plant and Food and others using that Epsom model. I know the Epsom model is also being used quite extensively by ag research. So it has extremely good potential for looking at how the benefits of adaptation as well as just the impacts. Here's some work from friends at Manaki Whenua Lanka Research, and this is looking at productivity changes in Pinus radiata. So this is work that Mikko Kirschbaum led. And here we're looking at, in particular, the impact of keeping carbon dioxide constant and just looking at the impacts on Pinus radiata productivity based on those climate changes, versus including an increasing carbon dioxide concentration in the mix, as well as the climate changes. And it's really clear that having CO2 increasing in the model is vital to understand the full implications of changes in productivity, productivity on Pinus radiata. And so it can go from essentially negative impact to quite a lot of positive change here now. So particularly South Island and Central North Island. So the takeaway message for that is that this modelling work that's looking at impacts has to include carbon dioxide changes as well, because that's obviously a way of increasing productivity. And another piece of work here, this is looking now at pasture production from folks at GNS. This is Troy Baisden and Liz Keller's work. So this was looking at pasture production, and they have a way of sort of saying, well, was it a pasture based on sheep grazing or dairy grazing, just a sort of a tweaking of the model and various parameters. And here it's, again, without carbon fertilisation changes and with CO2 fertilisation effect. And again, you can see that it's a significant difference if you include CO2 fertilisation in these models. Without CO2 fertilisation, the whole country, essentially, well, particularly North Island, is looking at decreases in pasture production on the order of 5 to 10% by the end of the century. Like this is again based on this high RCP, but with CO2 fertilization, it actually turns around to positive effects. So it's again critical that that CO2 is included in these models and to some degree even outweighs or balances out the impacts of climate change, of the physical changes in climate. Finally, this is some work that I was involved in the project looking at Hayward's kiwi fruit variety. And what we did here is we looked at the number of years in a sort of a 20-year period into the future where you would get good or marginal growing conditions for Hayward's kiwi fruit. And what you can see here is that in our traditional areas like Bay of Plenty and even up in Northland, the number of years out of sort of that out of 20 in this end of century period is now sort of around about 50% or even many fewer, and getting down to 0 years in that sort of 20-year time frame. But there are certainly a lot of potential in other parts of the country where 20 or 18, 17, 18, 19 years out of 20, there's still good or marginal conditions, climate conditions for growing Hayward. So what this really does indicate is that that the kiwi fruit industry will certainly need to adapt to where they're currently growing Hayward's kiwi fruit, and they are adapting by looking at other varieties, of course. But looking at other places as well as where you could grow certainly needs to be on their radar screen. The difference between these two maps, the left and right, is very, very interesting and quite stark. You can see that there's a massive decrease in the number of good or marginal years in that sort of future 20-year. And this is when you don't have this, and you sort of restrict yourself to not being able to apply this chemical called hydrogen cyanamide, or hycane I think it's called, which is a way of stimulating bud break when your winters are too warm. And there is some debate about whether we can continue in the kiwi fruit industry to use this chemical. So if that comes on stream, or if there's no other similar type of application to stimulate bud break in the winter, then the number of locations where you can currently grow, where you could grow Hayward's kiwi fruit reduces quite significantly. But there's still potential. So I think that the kiwi fruit industry is still certainly viable in New Zealand, but it has to go through some really long-term strategic thinking about what it's growing and where it's growing it. And finally, Harry, so just to try to sort of sum up the research picture at the moment in this space, it's quite a challenge. Angale, or say from Manaaki Whenua, had a go at it in terms of where, sort of on a matrix of between different agricultural crops, pasture, arable and horticulture, and then projects that are looking at more at current versus long-term versus long-term effects versus changes in extremes. And a lot of that space is actually taken up at the moment by the Deep South Challenge and our Land and Water Challenge, looking at climate change impacts on land use suitability. There's also some various other projects that we know about, MPI's Sustainable Land Management and Climate Change. There's a horticultural footprint project that's being led out of Plant and Food Research. Plant and Food have also got a discovery project that's in this space. There's another SLIMAC project that we're aware of that's looking at adaptation pathways, focusing in on the Hawke's Bay. And there's another project that's looking at these future low emissions options, which does also sort of map into this space as well. And as I said, this is just sort of Angale and myself off the top of our head trying to put that, have a think about that research space. But you can see that even from what we understand is going on, there is a lot of work that is going on in this space, and the challenges are being included in that, as well as the research Crown Research Institutes in Victoria and universities. So we're very, I suppose, we're fortunate to be in this sort of space at the moment. There's certainly a lot more that we can do to better understand not just the impacts of climate change, but what we can do to adapt and the benefit of doing those adaptations, such as what was shown with Edmar Texiera's work in Plant and Food. So thank you very much. I appreciate it.